Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. So I decided to try a different tactic here. I was sort of doing some basic checking around, I couldn't find anything obvious. Now I found a few rabbit holes to go down, nothing really ended up eventuating to be a problem. At least not yet. So I've cleaned all the controls, that hasn't made any difference. And if I probe on the auxiliary input, or auxiliary output, which is around here somewhere, do it by feel. There we go, there's some pulses on there. Right, seem quite low there, but they're there. So I should be able to see that on the output, but I'm not. So I was looking at internet between the output card and the main control board. Now that is the connector there, it connects everything together, just there, and that's everything. Everything goes through that connector. You've got voltage and the control signals. There are no other connections on that board apart from the one which goes out to the output pin. So the fact the auxiliary is working, the output isn't, and I believe it's this card isn't generating an output. Thought, okay, let's narrow this down a bit more. I need to be sure which card I'm supposed to be looking at. I've had a look around this card, I can't find anything yet. I've got Manchester, every single diode in it, diode test mode. I found one which seemed a bit weird, but I soldered it and it was okay, so it wasn't an issue. Must have some circuitry around it, as you get. Voltages check out. I've tried substituting op amps you were seeing earlier in the video. So right, okay, so this connector here, this has the 40 volt rail, which is like the plus minus 40 volt rail, so it's these two connections here go to that connector. So there's doubled up pins for that one, doubled up pins for that one, doubled up pins for that one, doubled up pins for that one. Those are all power rails. So those two pins there should get the same voltage from both. So that is minus 18 volts. That's minus 18 volts, so it's definitely connected through. Next pin is 21 volts. And 21 volts, I'm rounding this up and down a little bit, so that'll allow 40 volts across them. So the next two pins are ground. Then we've got 6 volts. I'm getting that there. Next pin, yeah, getting that there. So that's the power supply pins. It leaves me 2 more pins. This one here, and this one here, which should be signal lines. I'm getting nothing there apart from a little bit of noise. So I've just been probing around, I've just playing with controls and stuff on the front. I've adjusted these ramp times and what have you. And now I've played around with those controls, I'm actually getting some signals here. So these are the inputs to that board. If I probe on the connector, you can actually see pulses there. It's kind of noisy. I don't have a ground reference and stuff like that. I'm floating, but there is something there. I can adjust the slopes. So the slopes are adjusting. It will do it. Alright. Change the ratios. The problems I had a ratio like there before, so I was getting nothing. The slopes were actually too short, so I wasn't actually getting pulses properly. So yes, the signals are going in. Right, so at least now I do know it isn't on this board, it is on the other one. We get in there. There's only 1 volt division though, so it's a bit messy. Now it is seemingly ground reference, so maybe I'll stick my ground probe on and clip that on somewhere. I think that's a ground. Hopefully without shorting anything out. See if that helps clean it up a bit. There we go, that's better. It's a bit cleaner. Okay, so and there's the slopes. Alright, so that is all working. Actually, those controls are working. I'm trying to test these, just feeding these op amps down here. Yeah, warmish, not too bad, there's nothing obvious. Transistors feel okay. Ooh, one of those transistors is really hot. That one there. Or was that the one next to it? No, this metal one here. That is really hot. Interesting. probably about 50 degrees. That seems too hot to me. BH68X2N2369. So there are some metal can types there. Let's just pop this out and have a look at it. BFW10, BPW10, something like that. It's my transistor tester. It's got 4 legs. Okay. In that case, I don't know what the hell this is. Depletion mode, in-channel MOSFET. That's what it's finding in that direction. So I need to try and find out what this thing is. Let's see if it's got any shorts. Or maybe it's be chasing something which isn't a problem after all. I mean, I don't know, I'm just guessing right now. So you got 2 pins to the other side, then swap it around. And turn it around by 90 degrees, try again. No short. Another 90 degrees. Same. It's getting 116 ohms across 2 of those legs, regardless of polarity, so that may or may not be a problem. What is this thing? Well, let's go and find out what, if anything, I can find out about the device. So I had a close look at this part here. It's a MOSFET, in-channel MOSFET, silicon MOSFET apparently. So I found a double sheet. It's a BFW10. Is it okay? Yeah, probably. I did some voltage measurements on the back. It seemed to be okay. So I moved along, and I've got these 2 parts here which are both heat sinked. And this one's hot, this one isn't. So I've done voltage measurements, well, with the scope, and I can see a waveform in this one, in and out, presumably out. I have to check the pin out. This one here, I don't have that. So if this is a push-pull complementary pair kind of thing, that one doesn't seem to be working, and that's the one that's not hot. Right, let's just try and probe around here and see what we get. Turn the power on. Now, pin 1 is the hold on, emitter. So it's emitter based collector is the sequence we're going to probe in. Okay, just in theory. Let's see what I'm doing. So that should be emitter. Not much there. Very low level. We can see there's something there, but it's very low. But it is a waveform as well. Okay. So that's emitter. This is base. Exactly the same. And collector is lower. So make of that what you will. Does it make sense? Not really. I mean, it's an NPN device, so it should be a bit different to that, I suppose. Anyway, let's look at the other device, which is the same. So I can try and balance this and see what I'm doing at the same time. Pin at the bottom, which I think is that one there. So that is off the screen. That's helpful. Emitter, that's base, and that's collector. So there's a very big difference between those 2 devices. Now let's probe it with the meter and see what we get. Balance it there so you can see. See if we get any weird readings from this thing. So in diode mode. No, that's not actually shorted. That seems interesting. I've got the same both ways onto the emitter, but it's not actually shorted. Just to check the other device as well, which is also hard to bloody see. Buried right down there. Just trying to get a position where I can actually see what I'm doing. So base to emitter. base to collector. It's given the same kind of readings. Yeah. Inconclusive. It is not a short. That's what I can say. This has been quite tedious. Okay, I've decided I'm going to take this board out. I've had a bit of a close look at it now. I think I can see how it comes out. It looks like you slide it out the bottom. So you got this heatsinks in 3 pieces. So that's one piece there, well, those fins, that section. So it's got 4 screws to hold it on. So I've just got to loosen the top ones off, take the bottom screws right out. That will allow this part to slide. I have to take this little bracket here off, which probably means taking this bar out. Probably not a big deal anyway, looks like it slides anyway. So I've got to take that screw there out. I think I can probably get that bar out. There's a couple of screws in the circuit board here and here on the corners. Those have got to come out. And now I've got to do something with these knobs here, these sliders. Either pull these knobs off. I don't want to pull off, so I'm not going to be doing that way. But there's also got screws on them, so I can probably get to those screws and just detach them. So just here, just there. So I think I'm going to do that. I'll take these knobs off first. It looks like it's, yeah, that's off already. That's pretty easy. Do the same on the bottom one. Make sure it's free. Yep, that's moving off. Yep, they're both off. Means I should better pull it out this way a little bit to get those off. They'll probably fall out when I do that though, it's any problem. Make sure we're definitely not going to lose the screws, but also make sure we're definitely off. Right. Let's try the circuit board ones. My screwdriver might be a bit small for this. It is. I do have another screwdriver here somewhere. Have I lost it? This one's got to come out completely. Okay, that's that. Loosen the top one off. Also got to take off the connector here for the hatchet output. This can just be loosened, it should be alright. Loosen it right off, so that's got some flexibility there, but movement. I've got to undo that. Let's try and find a spanner. Okay, I've got a spanner, it's an 11mm. That seems awfully tight. Oh no, there we go. Just borrow it for a second there. So I hope that means that'll pull out. It will. Oh, that's an interesting design. So that's actually the BNC connector. Bit of corrosion on there. It is silver plated stuff, so it's probably nothing. Bit of oxidisation most likely. I'll get a closer shot of this. There you go, you can see it's got this dark tip. Interesting. Anyway, we'll carry on. So that's that loosened, that off, that doesn't matter. I'll take the heatsink ones off last. Got to take this off. Try to get this one off. Oh, it's not a screwdriver. Let's get it in the screwdriver. It's very tight. Anyway, it's coming. So is that going to move now? And there's a standoff here which goes through to the bottom of the board. So I've got to loosen that off as well. We'll take it out. Okay. Now that moves great, I can get that out of the way. There we go. Now I can do the heatsink. So that's definitely free of that end. This end here is kind of free. So I think it's just connected on that circuit board which is holding it now. So if I push it here, just gently try and ease that out. There's something else holding there. Okay, that circuit board's unplugged. That's unplugged. This should now move. I can't see what's holding it. I'm going to have to take that off, screw it. Might have to, it's kind of trying to tip. Let's take that circuit board, screw it. This one over here. And I can't see because they're facing away from me because that's a bit dumb. Right. Take that out. I think it might be hitting on that corner. Ah, one more thing. This board here. Okay. Missed the one. This board has to come out too. And it's got this. That is a plug-in. I suppose I could do that. Is that going to work? Probably not good to be bending it like that, but I'll pop this board out. Get out of the way. Okay, so that's definitely free there now. I think that should now come out. If I have, oh no, there's more. There's his wires here. Okay. Green, blue, orange. Same sequence here on front panel. Okay. Unplug. Maybe now. Yep, that's going to come out. Okay. There we are, it's out. Now I can have a really good look at this thing. I'll take some more photos of it too. Now I've got the thing out, I can see it properly. Let's do that now. Just do a bit in case I need to get different lighting. Okay. So what we've got to deal with here. Now I can see it better. Probably should have done that in the first place, shouldn't I? So those RF transistors there, I was saying about there's 3 of them. BLX93, BLX67. There's some inductors, a couple more diodes. Okay, let's do some testing on this stuff. Now I've got them out, I can actually get to them. See if these look like they're okay or not. And you can't see what I'm testing, can you? Hold on a second. Emitter, nothing. Go around. 600. 600. I'll show you this one again. So this output device looks to be okay, though it did that interesting level on that one, reverse biased. Maybe nothing. So we've got the BLX93A. Let's do the same test on that one. To emitter and there, I think those are different. Okay. Not sure if it's a 4-pin or 3-pin device. Yeah, okay. There. Okay, that's base down the bottom there. Right. So those big transistors seem to be okay. So this is nothing obviously wrong with them. We had the flex there, which goes, well, the coax goes down the front panel. These resistors were getting warm. So I'm trying to trace all this stuff out. Now I should check these resistors to see if they look like they're the right values or something like it. .48. 48, I think these are all in parallel. These are all minus 300, so that'd be right, would it? Maybe. Go there to there, should be the same, yeah. Those linked as well or not? No. That one is. Those are together as well, so yeah, there's 6 of those in parallel, it would seem. Yep, 6 of those resistors in parallel, so that's 50 ohms loading it's doing on those. So that makes sense. We've got these ones here, getting 6 ohms. I think they're in parallel. Maybe. Uh, 10. This mark is 10 ohms. And yes, they are in parallel. So that end to that end again. 5, yeah, okay, that's alright. So we've got these other ones down here. That's marked as 10 ohms. Getting 5, so that's probably those two there together. Looks like it. And we've got this one here, which is 10 ohms. Right, so the resistors themselves look alright. These big power resistors anyway. So I'm now closer. Think about this. See what else I can check. So I found something. This big inductor here, this big blue one, you see that it's not soldered properly? This side is not really done. It's soldered on the other side, but I'm always suspicious about relying on wires. So I think I'll go touch that up. See if that helps. It might do. So I'm still just inspecting this thing, and I mean this 14-pin device here, I'm suspecting it's like a custom quad op amp or something like that. It's got an HP part number on it, not HP, a Philips part number on it. Well, I think it's a Philips part number. But it does seem to have quadrants. So this bottom quadrant here goes to one transistor, which then goes to another big transistor. And there's another big transistor up here, which I showed before. That one, which again goes to another transistor over here, which feeds down through a resistor to this quadrant. So it seems like it's got a quadrant here, quadrant here. I know when I was doing testing I was seeing quadrants over here and here as well. So I think it is a quad op amp. I might have to trace it back some more and just try and figure that out some more, but it might be this device. Anyway, and I was looking just now right here, see that? On a really badly soldered device, or component leg, right there. I mean, the soldering on this thing is actually really good. See, it had very few bad joints on it, and I've just found this one. So I thought I'd just show you that, you know. So I'll resolder that as well, just in case. Right, so what I'm going to do now, I'm going to take this heatsink off this board. Now these devices can stay on, because I'll just plug back into the board anyway. But I need to remove these 3 bolts here, or these nuts, which are hold on those RF transistors which are in there. And then that screw, and I should be able to then take the board off. So we'll just find a spanner which will undo these. Okay, I've got my 9mm nut driver. I should be able to take that screw out, and that should then release the board. So worry about flexing it and anything too much as well. Putting stress on it as I'm doing it. So it should lift off. I should be able to pop all these devices here out. No sockets are in theory. That one's going. So my arms in the way, you couldn't see what I'm doing, can you? Right. There's one device which is being a bit hard about that socket there. Coming out now? I think it is. Here we go. Right. So I just wanted to check under here and see what's actually on here. So let's do that. Let's show you that close up. No signs of bad joints that I can see. You can see someone's been here resoldering, which is always interesting, isn't it? So like I said, someone's been in here trying to fix this before, because there was that missing screw and there's other bits of flux around. So someone's already had a go at this and not made any progress and been suspecting it's been the upper stages. But it hasn't been, or it doesn't appear to have been. And this is wiggling very slightly. But I don't think it's actually moving the joints around at all. Is the joint moving? Actually, I think it is. Okay, we'll check this one. That one feels really good. So is that one. I'm actually suspecting that joint right there. I think it's moving slightly. So let's resolder that. It looks very different now. Just do this one as well. Maybe that's what the problem was. Let's push it down as well. Just better right down properly. That's getting hot. I have to let it go. And this one too. It did look like they were cracked. The other devices look okay. I don't know. So I found a few bad joints. That's, you know, that's always a good thing, finding something which is wrong, rather than finding nothing which is wrong. But yeah, you can see someone else has been having a good go at this. And like even in on socket here, it's all been resoldered as well. That wasn't me, that was somebody else. The cap's been resoldered as well over here. See flux on there. So there's lots of things been going on here with someone else, which is sometimes a problem because you never quite know for sure what could have been hidden by their work. You know, what problems were there which they've fixed, which may give a clue to what's going on. You know what, the other end of those caps doesn't look great, and there's a lot that need resoldering too. No, maybe they're right. This looks like they could use a touch-up as well on this side of the ball. I only did half the bloody job, can't I? So otherwise you can't see what I'm doing, can you? If in doubt, touch it up. It's pretty simple really. You never know, if that one little thing you overlooked could be the problem. Right. Well, I've got these other transistors over here which I haven't tested. I suppose I could check those now it's at the chassis. Hmm. 0.4, 0.4, so it looks like that's the common, the base. And we'll check the other one as well. Low both ways, but there may be circuitry around it. No dead shorts at least, so it's okay. Right, we found some problems. Maybe it was it, maybe it wasn't. I just pulled this transistor here out because I was suspicious about the reading I was getting from it. Now this is the one that was sitting here, and if I stick the component tester on it, see what we get. This is a great little tester from Peak Electronics. I'm hoping to get some more stuff from them soon actually. See how we go with that. No component detected, which is unusual, right? It should be able to find a part. Now, and obviously I pulled this because I got suspicious readings from it in circuit, you know, using the diode test function on my multimeter. So let's pull this one out. I've already desoldered it. Pull this one out and do the same test, exactly the same part. Right, so it should be the same reading. Doesn't matter which way around these leads go, they're all universal, doesn't actually matter. What's this one, I think? NPN silicon transistor. Which means this one, which was getting warm, 58 gain, 0.8 volt. Okay, that's fine. So that transistor looks okay. It looks like the other one isn't. Now when I was testing in circuit, this transistor here was getting warm, this one here was not. So that's why this one seems to be dead. If I turn it off, that does all the power off anyway. If I use my multimeter instead in diode test mode, see that on screen there. Now this is the apparently bad one. Now I'm going to have to kind of hold this together because it's a bit tricky trying to hold it like that. Now nothing there, right? Swap the probes around. There, no, nothing. There to there, nothing. There's just me flipping the probe into the other one. Completely open, there's nothing at all on this device. Let's check this one. I believe that one there was the gate. 686, 690, so yeah, that's the gate there. So this one's giving readings, that one's not. This one's stuffed. So now I know what's wrong with it. That part's gone. Or at least that's one of the things that's gone wrong with it. So I'm going to put the original one back in again to where it came from. The good one, which is that one. And I'm going to have to get some more of these. BFW16A. Well, at least I actually found something wrong. Finally. Okay, it's been a little while. A few weeks later on, the parts have arrived. So I can now carry on repairing this thing. Alright, so you've got the part that goes in over here. Sits right there. Here's the original part, which needs to be replaced. It's got a little heatsink on there, so I've got to try and get off. There you go, pops it off. It's also got this little spacer that goes underneath, so I'm going to make sure I put that back on too. So, yep, BFW16A. Now I managed to find some from UT Source. I use that company from time to time and I have trouble finding the right parts. From, you know, brand new parts from places like RS or Farnell or, you know, 1114 or whatever. You know, if they don't have them, then they usually go to the E2 source, and now they may have some. These are either fakes or they're new old stock. If they work, I really don't care. To be honest, I just don't care. I just want it to work. So it's just poke those through those leads. It's got this little space that goes in the bottom there, like that. I've got the heatsink. I'll put that on as well. It's actually, I'll put it in exactly the same way the original one was. I wonder if I should put some paste on there. I think I will actually. I'll put just a touch of paste on it. I do get warm, so I just want to preserve it a little bit. Probably doesn't matter too much. Yeah, just going to put a little bit on there. Yeah, well, it's got a little bit on there now. I'll do something at least. Alright. Smear it around. It's probably not important, but I like to put thermal paste on things. Just helps to guarantee it's going to work nice. Maybe that's why it blew in the first place. It got too hot. We've got the other one here. I'll do the same on that too. The heatsink comes off quite easy. It's not that tight, so maybe it does need a bit of assistance. Just do the same on this one too. Okay, wait a minute. There we go. That should probably be enough. Just a little smear. And I shall try and smear it around the whole thing by spinning it. Right, it's going to help it, isn't it? When it doesn't fall off, it should be fine. Just don't like to have things which are supposed to be heat sinked, not having thermal paste on, especially when it's blown previously. Right, better get my iron turned on. So it splays legs a little bit, so it'll go in a bit easier. I'm hoping this is the only fault with this unit. Just try and get it flat on the board. Yeah, that's alright, it's not moving. You probably can't see that, can you? Anyway. Let's get closer. There you go. Now, see if I can get in the way so you can't see anything anyway. There's the joint I'm trying to do right there. This particular solder's got very little flux in it, so let's see how we go. The joints seem pretty good to start with though, so I'm not too worried. Oh, it's in your way, isn't it? Alright. Yeah, I'll do it an awkward angle for it so you can see. How's that sound? Okay. I'm pretty sure that's good. I'm going to put it back together and see what happens. I'll be right back. Right, I've reassembled the unit and I'm going to try powering up for the first time. I've got the scope connected. Let's turn the power supply on. I want 230 volt or so. Yeah. I'm using my Variac, so just plug into that. Power is on. Okay, let's see if we can get anything out of it. Hey, yes, we have activity. I seem to have a lot of noise, so I may just, yes, it's this cable. Not the best connection. It is working. Let me show you. It's working. Yes, that transistor was what the problem was. It's fixed, and that was without a service manual or any circuit diagrams. That's purely just checking componentry. You know, that's pretty cool. I'm very happy with that. Obviously, I need calibrating and that sort of stuff. I've got no idea how to set this delay stuff up. Delay seems to be doing nothing. Duration seems to be doing nothing. Oh, anyway, so it looks like it needs calibrating at low heat at the very least. Slopes are there. Though you can see that on screen. It seems to be kind of there, but it seems not quite right. The delay doesn't seem to do anything. So switching duration also seems to be doing nothing. but it might be more to do with the setup I'm using. It actually has an output now at least, which is more than we could say before. So that's 243 Hertz. Let's look at the auxiliary output instead, and we'll see if this does anything on those. No. Okay, on the auxiliary output this is doing something. Let's get a closer shot of the camera on the screen there. You don't need to see this bit necessarily. Let's make this a bit better. Duration is working on the pulse mode output, but auxiliary output is working for duration. Okay. And delay is doing something, but not what I expect. Let's see. Oh no, it's working in that position there as well. There's something definitely going on a bit funny here. Not that position, so only in the milliseconds, 1 millisecond, 10 milliseconds positions is delay working in that one. Delay's only working 2 positions, so there's something definitely wrong with that delay section. Right, so 1 millisecond, 10 millisecond works. Yeah, something's definitely going on with this part. Right. Anyway, you're getting that triple pulses there. It's not supposed to be doing triple pulses. Yeah. So something's not right with that part. So but we do have an output now. That's the pulse output. Let's go back to the main. Sorry, that's the main auxiliary output. This is the pulse output. Let's bring these levels up a bit closer. Right, so if I just play the transition times, so I want to check these. Transition stuff's definitely working. At least it seems to be. Yeah, something funny about the auxiliary output. I suppose you 1 millisecond of division out there, and we'll see if we can get that to actually line up. So 1 millisecond is about very close to there. So yeah, that's not where it actually has the marking on the front panel. So that's a bit different, but it's doing 1 millisecond. So do 10. So it should be 10 milliseconds. But it's only doing about 5.5. So yeah, it's definitely out of calibration because it's definitely not lining up to where it should really be. I have to do 100 microseconds. And again, try and get this so it's in about the right place. Which is, in this case, is about there. Slightly further. Close to there. It's about the same place as the 1 millisecond one. Okay. 10 microseconds. I just want to check to see if the timings look about right. I've got it set of 5 microseconds on here, but that's alright. Then it should be over 2 divisions, that's about right. 1 microsecond. Oh, sorry, yeah, 1 microsecond, get it right. And that's slightly out, but bring it down a bit. So yeah, we'll do it. So it does definitely need calibrating. Let's go 100 nanoseconds. Now we get a bit of noise and crap on there. Are these doing anything? No. No, they're not. So we're getting some ramping stuff happening at 100 nanoseconds. So it should be 2 divisions, which would be about there, minimum position. So it's always a different place each time on the knob, so it's not quite matching up. It's offset, so yeah, it definitely needs to be aligned. And as I slow it down, it all goes out of whack and changes levels and disappears. I might need these new caps or something like that, but it's working at least. There is an output. That part is good. Now I figured out what was going on before when I was trying to get these two controls here, well, these four controls here to work, and they weren't doing anything on the pulse output, but they were working on auxiliary output. The reason is it passes, this is set to square wave, right? So, because it's square wave, these controls are disabled. It passes that signal through to the amplifier board and it does a square wave, or something like that anyway. So I need to set it on pulse. Now we've got pulses, and now I can actually control delays and durations. However, there is some issue here. I don't know if you can see it there very well, but every once in a while glitches. Right, this thing, see it? It's like, what's that second pulse there? What the hell's that? That's not meant to be there, right? And there's some runt pulses and false triggering going on here. It's putting out some runt pulses. We get in the right place, you actually see quite a bit of them. If I adjust these time bases a little bit and try and get it, I'll zoom into the scope so you can see a bit better. You can see some jitter there already, and as I turn the controls, it gets very jittery. Even though I've got, you can see my trigger point is certainly well within range. Trigger point's a little arrow on the side there, a triangle. So it gets very jittery and stuff like that. So if I turn this control down, turn this control down, you can see those extra pulses in the middle there. You see them? So you've got the big pulses, then you've got little spikes in between. So there's got like 4 of them in that one. Yeah, there you go, see them all in there? These little lines. So something's definitely going on with this circuitry. It seems to be, I'm not sure if it's delay circuitry or whether it's the duration circuitry. One of them's firing, you know, erratically like that. Maybe there's some ripple on the lines and it's causing it to trigger. Maybe it's some, you know, some coupling issue or something like that. Decoupling's not right, where capacitors are aged, so it's ringing and causing it to trigger. I'm just speculating here. I've got no idea yet. But at least I now actually have the circuit diagram, so I can actually go and have a look. So yeah, and it does do things like have double pulses from time to time and things like that. So it's doing some weird stuff. Let's bring these delays down a bit. I see that there you go, double pulses there. Well, it's only set the single pulse, and yet you've got 2 pulses coming up. Right? And with jitter, and you know, there shouldn't be 2 pulses there. So that's basically 1. When I bring it out, it will actually eventually change. If I get the right setting. Yeah, there's 1 pulse there now from duration. Right? So that's increasing the duration, I get 1 pulse, which is what's supposed to be there. Right? So yeah, it's this is adjusting the delay. Once you get above a certain point, it seems fine. And this is turning down the duration. Then I suddenly get 2 pulses, or maybe 3. It's a bit hard to see. I could do a single capture, couldn't I? Still single. There we go. That's what I'm getting there now. That's 3 pulses. So yeah, not much good. So there's obviously something going on there which is causing false triggering. So I need to try and figure that out. Again, you can see that sort of. I was gradually turning this knob, and that's what I should be doing there. I think that one there. That's almost all the way up. That's all the way up there. All right. So as I bring it down, then you get jittering. If I increase the delay enough, then it seems to be basically okay. If I increase the delay, apart from like there, I haven't got quite enough delay there. I'm guessing. Maybe, I don't know, but yeah, it does. Yeah, so there seems to be something going on in that circuitry there for that timing. For the square wave, it's fine. Square wave, no problem at all. Obviously, my conversation's off because I'm just using a BNC cable, so it's not perfect conversation, but that's why it's got that starting point being a bit weird. It's mostly there anyway. I'll have to play around that and have a look and look at the diagrams now. Now I've got them, thanks to those guys that sent me the information, and I figured out names. Fabio and Harold. Fabio M and Harold Van something. Oh, so almost got it. There's two guys sent me those manuals. So one had all the really good high quality circuit diagrams, the other one had all the information about how to align it. So between the two of them I've got all the information I need, which is great, as I keep mentioning. Harold's also sent me something which I'm going to be doing a review on once it arrives. It hasn't arrived yet, well, at least not at the time of recording this video. It's a MacBook thing. You might be interested in anything to MacBooks. So thanks again to those two people which sent me the service manuals for this thing. Although I found the fault and actually identified the bad part before I had those manuals in my hands, they are still definitely going to be invaluable for future care of this thing, future maintenance. And one of them has all the alignment information in it, which is definitely needed in order to get this thing back fully operational again. So thank you very much to both of those guys which sent me those manuals. You know, it certainly makes my job a lot easier trying to fix things. Obviously, just in this case, I was lucky enough to find a bad part. I managed to locate it, but it's not always possible. Sometimes you just need a manual and need a circuit diagram in order to make your job a lot easier, you know, or even to do it all. In this case, I was able to find it without the diagrams and without the service manual. Lucky for me. That's not always the way it goes. So thanks again those two for sending me those manuals, and you know, everyone down below should thank them too, because I'm going to share those things. I think I've already put them on my Patreon page. Yeah, and I did the first part of this repair video, the rabbit hole one. I put the manuals up on my Patreon. If you want those for the 5716, they're accessible up there. Catch you later.